This section is trigonometry, and unfortunately it's a huge part of this this sequence of work, and a lot of students here find this the most difficult portion of the work. A little bit of a wobble sometimes in what we just did, but here, and in essence, yeah, it's not an easy section, especially the piece where we do trig equations, but let's work steadily through it together, okay? And as we work, we'll find where we can put recipes down, we will, okay? We're going to do, I mean, you can see this. There's examples coming out of our ears here. But we're going to try and do as many examples as we can. We're going to make sure we understand the basic recipes of how to put trig together. And we're going to start with trig functions, okay? Trig functions. Okay, so let me put a note over here. Trig functions. Okay, and as I'm often told, trig functions. That just looks all right. Okay, what is a trig function? It's a graph. Okay, we're going to look at graphs of trig functions, right? Now, we know from previously we had sine x. Let's have a look. We've got f of x equals, or y is equal to sine x, cos x, tan x, which was a very weird shaped graph. Remember, it sort of looked like that kind of thing. And we're going to be drawing these. Just before we do, let's just recap quickly some issues. I'm just going to be putting in a graph over here like that. And where this got to a maximum and a minimum, okay, we said that there was called the amplitude. Those of you doing physics with me, you'll know that we've done this. The minimum is called the amplitude as well. All right, I am going to call this, and it is not, let us just call it a value, the height, okay, which is equal to amplitude divided by 2, okay? Because it goes up as far as it goes down, it means that if I measure from the bottom to the top and divide it by 2, I end up with the amplitude. If I know the amplitude, I can work out what that total height is, all right? As I say, it's not height, but let's just leave it as that for the moment, as just something to explain to ourselves what it's about. And what do we talk about here? The next thing is we say, we have the period of the wave. The period of the wave, okay, is along the x-axis, and it is the domain. It's measured in the domain. And when we're plotting a trig graph, what is x? We plot along here degrees. Okay, here, generally speaking, this goes from 1 to -1 for sine and for cos. Correct? This, I mean, if you just use your calculator, you can plot these graphs. They're very straightforward. Okay, and I mean, last semester, last year, you plotted these until they were coming out of your ears, remember? The period and therefore the range of these graphs, generally, the range was from -1 to +1, wasn't it? So the range was in fact double the amplitude, okay? The period of the graph, what do we mean by it? We mean the period is when it repeats itself. So it's crest to crest. I could go from there to the next crest, the trough to the next trough, or from when it cuts the axis on an up to where it cuts the axis on the up again. That is the period, is when the graph repeats its motion. Okay, and for sine x, it's 360 degrees. For cos x, it was 360 degrees. For tan x, it was 180 degrees. Okay, Minimum values, maximum values, 1, 2. We're generally going to be looking at sine and cos for the moment. We will get to tan. Okay? And tan x, like I put in my notes here, it's weird. Tan x, weirdo. Okay, why? Because tan x looks something like this. We said we went from 90 and over here 270. Let me just try and slow down a little bit. Hey, 270 degrees minus 90 degrees minus 270 degrees, and here we've got our 360. If we plot the tan graph, we get a graph that does this. Okay, and it comes and it repeats itself like so, and that was a pretty good effort, methinks, for a freehand drawing. And remember, we always on it, we put 45 degrees and 1. Okay, similarly, you could have had here minus, whoops, sorry, my bad, minus 45 is minus 1. Okay, minus 1. Tangent. Okay, let's just have a look. What is the amplitude of a tan graph? Amplitude of tan x? What? Not applicable. Okay, because it goes off to whatever. It doesn't have one. Okay, so we don't talk about the amplitude of a tan graph because it doesn't exist. Obviously, because it doesn't repeat itself the same way as sine. You think of a sine and a cos is like a wave in water, like in the sea, right? Tan is, like I say, weirdo deluxe, right? Amplitude not applicable. What is the period of a tan graph? Where it repeats is 180 degrees. Look, there's the period. It repeats every 180. Here we go. Okay, minus 90 to plus 90 is 180 degrees. It's the point where it repeats itself, and you can pretty much see that straightforwardly, can you not? Okay. Right, then the other thing is that we had to say in the graph here, we had asymptotes, and the asymptotes were at minus 90, plus 90, etc., etc., right? As you can see on the graph there, 270, minus 270, and plus 270. So we had the asymptotes at those points. Now, what does that mean? It means that the tangent, if you put in your calculator, tangent of that doesn't exist, of the asymptote. Tan 90, tan 270, they don't exist. Let's create another page. Now, let's have a look. Now we're going to look at y is equal to a sine x plus q. A cos x plus q, and of course we're going to look at, I'll put weirdo separate, tan x plus q. Once again, okay, let's just deal with sine and cos first, shall we? Why? Because they look the same. So let's look at sine x and cos x first, all right? Well, if you go and draw it, you will find that the graph makes that traditional, what's called a sinusoidal curve, okay? It looks like a sine curve. You have plotted them, therefore you know they go up, they go down. And essentially, what is the effect of Q? The effect of Q, positive, negative. So what does it do? Q takes the whole wave and it moves it up or down, doesn't it? That's all it does. The same, if you think about it, as all our other graphs we've ever had, right? Now, so therefore, right, what about the effect? I think that's pretty straightforward, isn't it? So if it's negative, okay, if it's negative, it moves the graph down, and it's positive, it moves it up. We're going to do an example, but those are straightforward. But what about y is equal to a sine x or a cos x, right? Let's plot. Okay, and remember, you can always plot this x and y equals sine x and y equals 2 sine x. Just going to get a feel for it. Let's plot a few. 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Just to get a feeling for what's going to happen. Well, if I put in here, I get the following, hey? Just with my calculator, 0.866 and a 1. Now, if I go y equal to 2 sine x, I essentially am multiplying this value by 2. So I get 0, okay? And I'm going to be multiplying 2 times a half, which is 1. 2 times 0.707, which is going to be 1.414. 2 times 0.866, okay? 0.866 times 2 is going to be 1.732. Should have known that. And that's going to be 2. Now we know that it repeats itself on the way down. So what have we done by putting in this a? We took the original sine graph, okay, over here, like that. And by putting in the a, we said, okay, can you see each point is doubled, isn't it? Okay. So we go to minus 2 and plus 2. But remember, each one of these to get up there is times 2. So therefore, the effect of a, what is a doing? Just a sickie, black. The effect of a, okay. The effect of a, okay, on sine x and cos x is to increase the amplitude. To increase the amplitude by, not the multiple, by the multiple a. So it just makes it peakier. And I have no clue on earth if that's a word or not, but it is now. So it makes it peakier. It squishes it up to the top. It stretches it to the top, okay? Which is a concept we've got to get into because tan is going to be stretched as well in that direction. Okay. So therefore, in any of these, it stretches it, okay? And we know Q, it lifts it up or puts it down. So now we say, okay, what happens with tan x then? Okay. Well, the only way to have a look at it is to say, let's have a look here. Say, right, y equals tan x. What are we going to do? Well, always use the 2 points on tan. Use x equals 0 and x equals 45 degrees. Because tan y equals tan of 0 is 0 and y equals tan of 45, which equals 1. So we have 2 reference points, okay? So that is why when we draw the tan graph, right, remember we said when we draw the tan graph, I am only going to draw it now between minus 90 and plus 90. Okay, that's minus 90. Okay, so I'm just going to draw it in here. And remember what it does. There's my points. So I know the shape. This is y is equal to tan x. Okay, so now let's put in this point. We say, okay, at 45 degrees we had 1, and at minus 45 we have minus 1. Now if we put in y is equal to, let us say, I don't know, 3 tan x or something. 3 tan x. Can you see what it's going to do? Let's put into your calculator y is equal to 3 times tan 45. So at x equals 45, that becomes 3. And this becomes minus 3. So what is it doing? It's doing this. But look, it stays going through 1. So therefore, A stretches the graph vertically. In other words, it does this. Can you see? It's making it more of a straight line. So we say that if A is greater than 1, the graph goes like that. If A is less than 1, the graph is stretched the opposite way. Because let's just have a look. Right? If it was, let's say, a half, this would then be down here, wouldn't it? Okay? Like so. In other words, we would be squishing it down towards the x-axis. Okay? So if A is less than 1, it drops it to the x-axis. If A is greater than 1, it pulls it up. Now, the same applies over here. Okay, let's just recap with these. Well, you say, okay, well then, what if A is less than 1? Okay, well, no, let me rephrase that. Okay, if A is less than 1, greater than 0. In other words, A is a fraction. Okay, and I'm also going to just change this over here as well. A, and just put it in the red, greater than 0. In other words, a fraction. Okay? Well, what would happen if it was a fraction? Okay, I would in fact be doing this, wouldn't I? Okay. So if it's a fraction, okay, I flatten the graph. Okay, so if A is greater than 0, A is greater than 1, the graph gets peakier. And otherwise, if it's a fraction, I flatten the graph. Please, when you get these homework to draw these, please do them. It really is not a waste of time. I know a lot of students say, oh, but this is such a... It's not. Teaching you to draw these, okay, is going to, in the long term, I can assure you, it's going to give you a feeling for the graph that is invaluable when you look at it and you've got a fairly complicated shape. You can see it straight away because you've got a feeling for it. You've drawn it before. It really is worth it, right? So don't skip through that or just write the answers down from the back of the book. Okay. Lastly, just a second. Lastly, I want to just cover. Okay. What about y equals minus 2 sine x? Okay, plus or minus q. Let's just leave the q out just for the moment. I mean, all the q does lifts it up and lifts it down. That's all. Okay. Well, what about this minus 2? What is going to happen? Let's look at y equals minus cos x. Where I like to start, and all I'm going to do is I'm going to draw this between 0 less than or equal to degrees, x degrees there, less than or equal to 360. So the cos graph, you know, does this, doesn't it? Okay. All right. And you know that's the 360 point. Okay. And if you're not sure, where does it go through the axes? If you can't remember, you know that's 1 there. Just put in cos of 90. Try one. Cos 90 is, there we go, 90 degrees. Okay. And therefore I can say, okay, well then you must be 90. You must be 2. You see? Try cos of 180. Cos 180 equals minus 1. There you go. Right? Just get used to using your calculator. Just remember the basic shape. Okay? But even that you can put together fast. Okay? Obviously, I've got a head start. I've been doing it for a while, but just the basic shapes are what you need to know. What is going to happen if I put in a minus, right? Well, what am I going to have? I'm going to have this, aren't I? Let's put a table, okay? If I put y, just clean up my table. X, I'm only going to put it from 0, 45, 90, I don't know, 180, okay? And cos x and minus cos x. Well, cos x is going to be 1. This is going to be minus 1. What is cos of 45? That's 90, and that's not. Well, let's do cos of 45. So you go cos 45 equals root 2 over 2. SD it is 0.707 minus 0.707. Cos of 180 is minus 1. This is 1. So let's just roughly plot what has happened. Can you see? So this is y is equal to minus cos x. So when you see a minus in the front, it has taken your standard graph and flipped it. Okay. In other words, it's multiplied everything by minus 1, which is what it's supposed to. Minus 2 will have affected the amplitude as well, won't it? What would happen if you had tan x? Let's just do a very, very rough tan x graph. Okay, minus 90 degrees and plus 90 degrees. And we know that our tan x graph does this, right? This is y is equal to tan x. And we know 45 degrees is how much, guys? 1. And minus 45 is, yep, minus 1. Those are the standard points. They're that one, and that one, okay? Well, let us now say that we have y is equal to minus tan x. What is going to happen? It is going to take everything that was negative and change it to a positive. So my graph is going to come down like that, isn't it? Because this one is now going to be at 45, I get a minus 1. And at minus 45, I get a plus 1. It's just swapped it around, okay? So that is why I say, just know the basic ones and just learn how to manipulate them for your own benefits, okay? And lastly, in all of these, obviously you've got, you've got the calculators where you can use the step function, etc., etc. Just remember the table. You can always go back to y is equal to minus a half sine x minus 3. If they ask you to draw the graph, 0, 30, 60, 90 degrees, and then do your 135, 150. But because you know it repeats, you only need to go to 180 degrees, right? Draw the first part. You know that the actual sine graph did that and it repeats there. What is going to happen? Well, this one has gone down, so the original was plus 1. That original now has moved down to, it's gone down by 3. So it's gone down there to minus 2, correct? That's where the peak is now, okay? Don't worry, we're gonna draw these. But this one here, this point has gone to minus 3. And it's minus a half, okay? So it has flipped it and flattened it, okay? So you're going to need some help from the coordinates, okay? Use the function, the step function, or if you don't have the advanced calculator, you can use the table to draw it, okay? It will all come out in the eventual wash. So just recapping, we need to know our shapes, standard, okay, sine, okay, cos, and whether tan is up there, right? We need to know those, okay? What we're going to do next is we're going to look at this in the next one, okay? Just remember we've got y is equal to a sine plus or minus q or Now just leave it as plus or minus. I am now going to put in an x plus p. Yep, remember this? Y is equal to a, x minus p all squared plus q. There's that, and there's the p coming in. So p and q are standard throughout, so watch your p's and q's. Okay, I've been dying to say that, but please remember that all we're doing is we're building up a series of functions. That is why I'm so keen that you draw some of them to get a feel for what's happening, especially when we now start with this p and q. I am going to approach it from a drawing perspective. Cheers, have a great one. Welcome to Trig again. And you know what? You'll all get through it. You'll get through it well. Let's just work through it together with the recipes. Remember the notes. Build up a little file of your own. Okay? Why? Well, simple, so that when it comes to revision, you don't have to look at the book and say, oh my goodness, there's my maths book. Where do I start? You've got your own little file in front of you with your own notes, your own shorthand. Remember, I'm not trying to teach you study methods, but your own shorthand, your own notes, it's your style. You can interpret it. The way I do it, the way you do it, it's not going to be the same. Okay? It's not going to be the same as the person next to you or anybody else watching this video anywhere in the world. Therefore, make your own shorthand. Follow the shorthand, the recipes that I give you, and the methods, and you'll just be cool. Cheers. Bye.